Okay, my friends, so we're gonna test these soda soft drink filling machines here. So we're selling them in 12-ounce cans, but we set the machine to fill to 12 and a quarter. That way, you know, it's America. You can get sued for anything in America, including not having enough soda in your can. So anyway, we've got it set to 12.125. There's going to be natural variation in that 12.125. The question is the natural variation that you see in this sample indicative that the average isn't 12.125 anymore? Maybe it's fallen lower. That's why I said, is it below? Is it significantly below the average of 12.125? So you'll notice when you look up here at the individual data points, 12.12 is low, 12.21 is low, 12.02 is low, but then there's also lots that are above the 12.42, the 12.26, the 12.28. So on average, are they below? Okay, so the first thing we have to do is we have to get ourselves a template sheet. So let's do that here. We're definitely testing an average, so I'll just do this and I'll color code what we're doing. We're testing an average. What is the average we're testing? I'm going to copy that down here. I thought I just made you red. You need to pay attention to me there. There you go. What are we testing? Well, the average in this case is going to be average volume of a soda can that's set to fill to 12.125 ounces. Okay, so we're going to see if that works. Make that red. Null hypotheses. Well, the null hypothesis is, or excuse me, the research hypothesis is that we're worried that it won't be. So this is going to be less than 12.25. The null is going to be the opposite of that. So I'm just going to put, let me see, I wonder if I can find the symbol for greater than or equal to. Insert symbol. I don't know if I can find G-mans. There's greater than or equal to. I'm going to use that one, G-man, if you're watching. I'm sure the other symbol's in there too, but this'll do just fine for us. All right, there's our hypotheses. Make them red. We're going to use a t-distribution because we're testing averages. And now we have to take a side trip to our Excel calculator and run our machine here. But in order to do that, we need to get these three numbers here. Now, one of them I know, there are 35 data points, and we're testing against the null hypothesis of 12.25. I need to get the average and the standard deviation. So what I'm going to do is I'm going to come over here and copy the data. Hopefully this works. Let's see. It's a table, so it should. I'm going to copy the data into here. Yep, that worked. And then here I can get the average of all that data. There we go. Which is about, that's low. That is low. But I also need the standard deviation of the data, and I got to take those values and drop them in. So I'm thinking this might be low, fam. I'm thinking this might be low because that's a low average and not much of a standard deviation, which means the standard error is going to be even less. So let's drop it in and see what happens, my dear friends. Let's stick it right here. I'm going to paste in the values. And we are definitely doing a left-tailed test. And yep, my little gut feeling was that, yep, the test statistics off the chart. Way past the critical value of acceptance, and the p-value is small. So the test statistic is about -4. P-value is almost 0. So now we're back here. Test statistic T equals -4.2. I don't know why I'm making these red. The p-value is about equal to 0.01%. That's what it was. We are most definitely going to reject the null hypothesis. We do not believe that it is equal to or greater than. It appears as though the machine needs to be recalibrated. And the reason, recalibrated, there we go. And the reason we think that is because, quite simply, it doesn't look like it's filling a 12.25. There's enough under, and they're far enough under. We could have made a type 1 error. Maybe it's working just fine, and we drew a weird sample, and that would mean that we said the machine needs to be recalibrated when it might not have to be. And this, again, this might not be the end of the world. This is one where it might be a false type 1 error, false positive, might be a, oh, I spelled it so bad, even autocorrect can't tell. Calibrated. Type 1 error might not be the worst thing in the world. It's just kind of like a vehicle recall. They pull back all the cars, even if there's a 1% of 1% chance that one of them might have something wrong with it, because they don't want they don't want any of the cars to have a potential Type 2 error, which is leaving them out there saying everything's fine. So this might be one of the ones that a Type 1 error is more desirable than a Type 2. Which, if you're watching this might help you in the on the exam you're doing. All right, my friends, I hope that helped. We'll talk to you soon.